Okay, we're back, and we have a short video today on introducing the concept of electrical resistance. This is something that's really essential for anything related to electrical circuits, different devices that you own. And I think we've probably all have noticed at some point, if you're using any kind of electrical device, if you have it on for a while and you touch it, even through like the plastic casing and things, you can feel some heat. That heat, I'm not sure if you ever wondered about this, but where's it coming from? Why do electrical things get warm in the first place? That's the sign of this thing that we call electrical resistance. And it's something that all devices have, anything electrical, except for very special cases of things that aren't part of your everyday world, called superconductors, but that's a whole different story. But everyday electronics, they all get warm, they all have this resistance as part of it. Now for mechanics, we're used to heat being produced when you rub things, when you have friction. Some people think of resistance as kind of like an electrical friction. It's not exactly the same kind of thing, but a lot of people use that kind of analogy. So our goal is to try to figure out, where does this heat come from? What exactly is this resistance property that all materials have? Even wires, right? Like electrical wires, copper, gold, silver, really good conductors of electricity, still get hot when you put an electric current through that. So first, we have to try to come up with like a physical model. We have to think differently than we do in mechanics, because in electricity, pretty much everything is revolving around what electrons are doing. You know, basically just about the smallest particles that we know about in nature. It's electrons that make the electric current when something's flowing through the wires and flowing through electrical devices. And we can't see them, right? We can't see these things with our eyes. And those electrons are flowing through materials. And materials, everything's made up of different kinds of atoms and molecules and all these little tiny things that are fixed in place. You know, if it's solid, you have this lattice structure where all the atoms are kind of in place to make up that material. And the electrons have to try to flow through that somehow. Okay? It turns out that the resistance is kind of, I want you to think in terms of like a pinball machine. If you've ever played pinball before, the ball inside there is colliding with stuff all over the place, and it's bouncing around. It wants to go in a straight line like anything, okay, kind of like Newton's laws. But when you have a collision, it's going to bounce and lose some energy, and all sorts of weird things happen. So I'm going to show you a part of a computer simulation. This is from a program called NetLogo. And what we're seeing up here is almost like a little piece of wire. Let's think of it that way. If you can make out the red dots moving from right to left, okay, these are electrons. Okay, electrons are negative particles, and they're being repelled by this negative side and being attracted towards the positive side. It's kind of like if you had a battery inside a circuit. That's setting up an attraction and repulsion, sets up what we call electric field that literally pushes those electrons through. The blue dots in here, those are different atoms and molecules fixed in the material. Okay, they kind of get in the way. And what I'm going to do is, we can watch a single electron to see what happens to it as it tries to flow through this little piece of material. And notice that it bumps into things. It collides with those blue dots. It collides with different atoms and molecules within the material. Every little collision makes the electron lose some of its kinetic energy. If you think back to mechanics, when you have collisions, billiard balls bouncing off each other, energy is transferred, momentum is transferred. The electron loses some energy every time it collides with an atom. Where does that energy go? Well, it makes the atom, because it's fixed, right? That's not going to move, but it's going to vibrate a little bit faster, okay, with every collision. Think about chemistry now. There's a lot of things going on here. The temperature of materials depends on the average kinetic energy of the atoms and molecules within that material. So if you can make those atoms in whether it's in a copper wire or whether it's in other types of materials that you have in circuitry and electrical devices, if the atoms in the lattice vibrate faster, okay, that's a more kinetic energy that it has in the form of like vibrational kinetic energy, and that's a higher temperature that we would feel. That's the heat that you feel in the material. Okay, so again, and this would be kind of like what would happen in metal. Okay, a conductor. There's not a whole lot of blue dots. I can increase the resistance on the simulation. I can add more blue dots, more atoms fixed in place. And if we watch electrons trying to go through here, notice it takes longer, right? There's more collisions. It's like trapped there sometimes, bouncing around in this really complex and really busy pinball machine. Let me show you another one here. It's all random. Every electron has its own little path. Every electron is colliding in similar ways like this. And every collision, remember, is losing the electron energy to the material, and that's the heat that we're feeling. And I can really crank up the resistance and put lots of blue dots in there. And these electrons, yeah, good luck. I mean, they're like, they're like contained in little populated areas there. Really hard to get through. This would be a very high resistance, a lot of ohms, which is the unit that we measure resistance in. Here's another one. Yeah, it's like those poor electrons. It's taking forever to get through there because of so many collisions and so much energy, so much heat being produced. Okay, that would be a high resistance material. Okay, so try to have those pictures in your head. That's the physical nature. That's the origin of resistance, are all those little collisions going through different materials. And different materials have different properties. Some are low resistors and better conductors. Some are high resistance and what we would actually call a resistor within a electric circuit. That's basically what's going on. Again, the unit, it's a kind of a funny name. It's from a German scientist, George Ohm. Has a little symbol, omega, capital omega. And it's like a horseshoe with feet. You'll see that when you start looking at numbers and measurements of resistance in materials. And also, if you get into circuitry and look at circuit diagrams, the symbol for a resistor is that little jagged line. In mechanics, we use that jagged line to represent a rough surface, kind of like friction. And we use that same jagged line to represent the resistor, the heat being produced in a circuit with that same symbol. So I hope this gives you a little bit of an idea of what resistance is and where it comes from. And there'll be other videos talking about how we put resistors in series and parallel, how to calculate the resistance of a circuit, and then you'll eventually get into actually circuit analysis and things like that. But this is the starting point, and everything in everyday life has resistance to it. So I hope this helps. Until next time, we'll see you later.